Okay, I am recording this video because I wanted to do a video about FPGAs, and I'm going to start off with why I even need to go into the direction of FPGAs. Uh, First off, what are FPGAs? FPGAs stand for Field Programmable Gated Arrays, and I'm presuming you don't have a technical background, and because of that, I think it's worth doing the little bit of explanation. So FPGAs are essentially a way that you can assemble circuit components for creating integrated circuits that help you create a programmable piece of board and allows you to, create computers on the go or on the fly. And essentially they allow you to program them on the field. That means you can rewrite the firmware or the hardware itself. You don't really have to delve with the hardware. You only need to reprogram the firmware, and you should be able to arrange some components of the field programmable gated arrays. So that's how far my knowledge goes so far. And I was first introduced to field programmable gated arrays when I was doing my bachelor's. And since then, I haven't had the chance to really deep dive into what they are independently. And I've always wanted to explore these FPGAs on my own, actually touching an FPGA board and making something useful. However, most recently I was attending Consensus Conference, and in that conference I came across one showcase or booth where they were basically claiming to have nanosecond level trading latency. And I was surprised to find that these systems, when they initially build them out, they needed some sort of ASICs. And if you're wondering what are ASICs, ASICs are application specific integrated circuits or integrated chips. And these chips need to be essentially created in the form where they have a specific reason. So if you're aware of general computing or general computers versus the difference between specific computers, it's kind of the main difference. In specific computing or spec computing, most often the specific chipset is made for a specific reason. And for that reason, in this case, these set of ASICs were made for running matching engines on order books or for trading purposes. Though they were proprietary, what they were able to tell me was that they initially do their prototyping on FPGAs, and once they have a working, essentially model or physical hardware that can run their algorithm, then they ship it to a specific fab, and then they get their ASICs manufactured. So that's the process that I've understood at a high level, and that gave me such an inspiration about FPGAs. Though like the only similarity that I can draw here is that it's essentially FPGAs are essentially the more generalized layer that you can use when you're compared to, for example, people often prototype on Raspberry Pis or Arduino boards. So FPGAs are kind of that layer or equivalent before you actually go into actually manufacturing the hardware that is necessary for that specific application. And this was very interesting because it gave me a sense that, okay, FPGAs are much more friendlier and easier to experiment with before, eventually hardwiring every component into a specific chipset. So that's what got me interested in why I'm trying to make this video. As a follow-up, I will be adding more to this exploration journey into what I find out, how you can actually build nanosecond scale order books. And of course, most of the technology specifically around this is definitely proprietary, but I would definitely be interested to recreate those open versions of the product. So I'm gonna end this video now. That was kind of my complete thought. I will follow up with more of the findings that I have.